Welcome to our read along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is subsection 5.2.4. Okay, so in the last subsection, we were talking about taking our function f, or a map f, which gave us a way of solving our congruences from like where we thought of the congruences living in here and we got its solution, but we can raise it up to a map up here, h, amongst free z modules. That's what we talked about last time. Now, what if now in particular, if we allow up here h to have the image, to send e1 to 4 and e2 to -3, similar to what we were seeing before. Where did we get this 4 and -3? Well, that was like this right here actually was the solution to 1, 0, and this is like the solution to 0, 1, but in the right mods. Here, we kind of removed the mods away, and we're just thinking of these as straight as integers. Now, if we have a map like this, and this is well-defined, if we just know where E1 and E2 are sent, we have a well-defined module map, we're done. Okay, so it's free up there, and we can just set things up like that, and we're good to go. Now, the question is, are we good to go down here, though? So we have to use some ideas there to make that work. Okay, how does this drop down to this down here? Okay, we want to show that this map f is induced. Okay, that we actually have this happening. So pretty much what we need is that the 0 here needs to be sent to the 0 here via the way that we're going to be defining this. All right, so let's start with 0, 0. Let's lift it up to here. That kind of looks like this. All right, then we're like 3z and 4z. That's like the zeros as we lift it up here. And then we run it through the chute of h and see where it takes us. That's what's happening here. So, well, first of all, this is like 3z times e1 almost, and plus 4z times e2. And then we take the image of e1, which is 4, and the image of e2, which is -3. And we have 3z times that, 4z times that. Now notice that this is the same thing. Multiplying 4 to this is like 12z. Over here, this is like -12z. And this for sure is inside of this 12z. These are because a multiple of 12 plus a multiple of 12 is a multiple of 12, which is that. So basically, we have satisfied this criterion right here, which means that if the process of pre-imaging, going here and sending it back, is a well-defined process that gives us the function f. So the function f quite literally is pre-image up over down. And that's the definition of f. That's how it would work. You can do that with anything here. And it's well-defined because we know that 0 is sent to 0. Okay. And that's enough even for seeing that it's a Z module map. All we had to do is just see that this map is well defined as a map that preserved the operation of addition, and we were good to go there. And the fact that it's a Z module map actually comes in from the interplay of using these Z module maps that are already in place. Okay, so we have this being well defined. This concludes this little tiny subsection. Thanks for watching.